It's a new millennium, where new technologies and new materials are creating new consumer expectations. And with new housing estates expanding into outer areas, a reliable cold water supply is more critical than ever. Of course, there are still standards to maintain. AS 3500.1.1 performance requirements is the first of the two standards you should be aware of. And the second is known as AS 3500.1.2 acceptable solutions. If you size your water pipes in accordance with these acceptable solutions, you are automatically meeting the performance requirements. Then it's up to you to certify that your work complies. And when it all clicks into place, everybody benefits. There are three areas to be aware of in designing water systems: pressure, flow rate, and velocity. So let's get with the flow. Rain feeds our rivers, water flows, it's delivered to the community, and when it gets here, whether it's for commercial or domestic use, things can get critical. The successful operation of modern appliances depends on the decisions you make here. They can affect product longevity, warranties, and even insurance claims. With self-certification, it's now up to you to maintain a professional standard. When it comes to pressure, it all starts here. Pressure is basically the difference between the elevation of the property and that of the storage tank or reservoir. It's not the size of the pipe that determines this. You should always measure the pressure. Once you establish whether you're installing in a low-lying area that has a high pressure water supply or in a high area that has lower pressure, you can calculate the real needs. So, how do we lose pressure? It's caused by the friction between the water and the pipe wall. There are two kinds of pressure involved: static, where there's no water flow, and dynamic, when the water's flowing. It's easy to calculate pressure loss using the formula in Appendix B of the standards. Fittings and changes of direction cause extra pressure loss, just when you least need it. Valves and other equipment also cause pressure loss at various flows. Fortunately, the manufacturer usually supplies a fitting and flow performance chart. Now, when designing, these days it's acceptable to use a design pressure of 67% of the static pressure in your calculations. This simulates a minimum pressure. When calculating for pressure or head losses, your standard sizing tables include 50% extra pipe length for fittings and valves. When it comes to flow rates, just check the required rates in your tables. And if you're using a water-efficient appliance, then the flow rate of that appliance can be substituted. In the design of a hot and cold water system with simultaneous flow, the selection of the correct pipe size and hot water unit will reduce pressure and temperature fluctuations. Water velocity is very important. Velocity simply means the speed of water through the pipe. A smaller area delivers a higher velocity for the same flow, and that can cause noise and water hammer problems for the consumer. Water hammer is caused by velocity, and you're allowed a maximum velocity of 3 meters per second. So get it right at the start, at the planning stage, and you'll avoid the problem. And when the water's actually flowing, you must allow for 50 kPa as your minimum requirement at your most disadvantaged fixture or outlet. At the end of the day, it pays to confirm your criteria. Check the available pressure, determine your flow rate, calculate your residual pressure. And calculate the water velocity using your pipe diameter and your flow rate. The new standards encourage you to use your initiative, and that includes using new materials and new technologies, including computer-based pipe sizing programs. As long as you meet the performance standards, finding the acceptable solution is up to you. And once you make that connection, everything else just clicks into place.